Good evening, ladies and gentlemen. How are you all doing? Awesome. My name is Sridhar Rajagopal, and I'm here today to tell you about how you can build your own Internet of Things device using Raspberry Pi and AWS. So what is the big hype about IoT? So according to IHS, there were about 15.4 billion connected devices in 2015 that will grow to about 30 billion in 2020, and blah, blah, blah. Now, IoT, maker style, so that you can do some cool stuff with it, right? That's what's important. When your device is connected to the internet, why is that nice? You can collect and store data from multiple devices and store it in a single place. You can invoke actuators on the device remotely. But more importantly, you can also integrate with other services. For example, you can send notifications, you can analyze data, you can take actions either on the device directly or externally. So the main point is combining hardware and software allows you to do a lot more things. So in my example, I'm going to show you a smart outlet. This has a bunch of sensors and actuators. The sensors get data about the voltage, the current, the energy data, and the actuators are relays that turn on and off the outlet. And by internet enabling this outlet, we can get remote access to its sensors and its actuators. And here are the components of my example. I have a Raspberry Pi Zero, and I also have a custom Pi hat, or bonnet as some people call it, that has an OLED screen, some buttons, LEDs, and also some connectors for connecting the energy monitoring board and my latching relay board. And of course I have my energy monitoring board that collects the energy data. I have latching relays to turn on and off the outlets, and of course I have the outlets and an AC input. So in my example, what can we do with the sensors and actuators remotely? So here are a few thoughts that one can do with this device. You can accumulate energy data across multiple outlets. So if you had this on main outlets in your home, you can get a good idea of the energy consumption around your house. You can send out text notifications, like text or push notifications on your phone, on interesting conditions, like if there's a voltage sag that might indicate a power outage, or an overcurrent condition. So think of if you're plugging in an angle grinder, say, and you're really like pounding it, then the current usage is going to go up, and that's a good indication of usage. You could combine data from the utility company's usage tiers to compute your cost. Or you can automatically turn off the non-essential devices, during peak hours to keep your usage within the tier, right? You could also look at the usage pattern over time. For example, if you have your TV plugged in, you can figure out what are your TV watching patterns. You can turn on and off the outlets remotely using a timer. So, at dusk, you might want to have your lights turn on, right? Now, in my example, I'm using a Raspberry Pi Zero. Why is that? It's relatively cheap for a good amount of processing power. It has a pretty small footprint. You can do programming in Python. There are plenty of libraries available to integrate with the devices very easily. And it has Wi-Fi connectivity right off the bat to connect you to the cloud. It has enough processing power to also serve as an edge computing device. And it also has support for TLS, so that means that you can now send your data and communicate securely with the cloud. This is an important consideration to keep in mind. Many people, think about, I'll deal with security later. I just have a bunch of sensors. Nobody's going to care about it. But if you start thinking about security right off the bat, it's a good tool to have in your toolbox. Now, why AWS? AWS has a free tier. You can sign up for it, and that gives you up to a year to play around with it and check it out. And after that, you're only going to pay for resources that you use. And more importantly, AWS has a multitude of services. They're managed services, so they're running on AWS. You can just use it directly. You don't have to spend a lot of capital getting a lot of machines. And this is a different computing paradigm. So you can focus on writing code, and you don't have to worry about the scalability and whether the service is up or not. So if I wanted a database, I could just go ahead and provision a DynamoDB, and I can start writing to it. And if I wanted to add AI or machine learning to my setup, it's also AWS has services to do that. It has a good number of SDKs and code samples, so that's really nice to get started. And more importantly, for our case, it has AWS IoT, which is a fairly comprehensive service, and they keep adding new stuff to it. And that will help you to grow as you go along as well. So to go to the AWS IoT page, it can be a little daunting. There are a whole bunch of services out there. So like, where do you start? What the hell do you do, right? So I'd say let's start with the core. Let's go to AWS IoT Core. This is basically an MQTT-based service. So if you're familiar with MQTT, then this would be pretty familiar to you. There is one key difference in that they offer something called as a device shadow service. The device shadow is used to get and set the state of the device over MQTT or HTTP, regardless of whether the device is connected to the internet. They have a bunch of MQTT topics that are reserved. It starts with $AWS/things/your thing name /shadow and a bunch of different topics for updates and delta and so on. So when you're interacting with the device shadow, there are a couple of things to bear in mind. One is device updating its own shadow. There is a distinction between the reported state of the device and the desired state of the device. The reported state is what the device is saying what its state is. The desired state is, if I want to turn on the outlet, I want to set the desired state of the outlet to be on. Then that message goes over to the device processes that information and turns it on and sets its reported state to on. If you go to the AWS website, they have a interactive tutorial. I would highly recommend going and checking that out. It's a nice resource to have to understand the concepts. And another nice thing about AWS IoT also is they have a rules engine. You can define rules to figure out what to do when messages come on to the IoT gateway. For example, you can take the message and you can write it to a database. So that way it gives you your time series data. You can send a notification using AWS SNS service. Or you can write your own code to take any actions that you'd like and run it in the cloud using AWS Lambda. And there are a lot more rules also available. Okay, that's great. Now, how do we get started? I've listed out the things here, but I think the better way to do would be to go over it pictorially. I've taken some screenshots because it's kind of hard to go and log in and do that with this Wi-Fi environment here. So you would go to AWS IoT and you would start with creating a single thing, give it a name, and you need to provision a certificate for it. That would allow for secure communications. There is a one-click certification creation. That's the most convenient to use. And at the end of it, they'll give you a certificate, a private key, a public key, and a root CA certificate. And you should download these and store these in a safe place, because after this step, they're not available anymore. The certificate might be available, but the private and public keys are not. So store it in a safe place because you're going to use it on your device and potentially your mobile app as well. Then you're going to assign a policy to it. The policies tells you what kind of permissions are available to that thing. So if you're provisioning this thing here, it needs to be able to communicate with the AWS IoT service. So I have created a policy called pubsub to any topic. So that's a very open policy. It says this thing can publish or subscribe to any service, but you can make yours a lot more restricted. So there's lots of permissions that you can set that makes it like really locked in. And then at the end of it, you would note your endpoint. This is the endpoint on AWS IoT that your device is going to be communicating with. Next up, you're going to be configuring your thing. All devices must have a device certificate, private key, and root CA installed in order to communicate with AWS IoT. And you also need to know the endpoint to communicate with. You'd also need to download and install AWS IoT Python SDK to start coding your thing. So running your Python program, I've created a demo which I'll be sharing subsequently. It's called Maker-Faire.py. And in that, I have a bunch of command line arguments. I'm going to specify what is the endpoint that I'm connecting to and where my certificates are located, certificate and private key and root CA are located, and also what is the name of the thing. I've used the following libraries. For the energy monitoring board, I've made a board called Dr. Wattson, and you can use a pip install to install that library. And I'm also using Adafruit's SSD 1306 for my OLED display. I would like to have a shout out to Adafruit for all of their lovely libraries. For buttons and LEDs, I'm using GPIO 0. And then for Raspberry Pi, the communications to my energy monitoring board is through I2C, and so you need to enable that. And I've also configured the communications to my OLED screen to be over SPI, so you need to enable that as well. And now your device is connected and communicating to the IoT service, and you can connect and interact with your thing remotely. There are a couple of ways that you can do that. You can use any MQTT client like mqtt.fx and use your certificate credentials to connect to MQTT and subscribe to the device shadow topics. Then you can see the shadow updates coming on the update channel. You can push desired state messages to invoke the actuators on your device. But why not make it more interesting? How about adding a mobile app to this? So I've gone ahead and I've created a sample iOS application. It has a bunch of fields that map to the sensor data that I get from the device, and I also have a button to turn on and off the outlet, and there is an LED light on top. And the difference between the button and the light is the distinction between the reported state and the desired state. So when you press the button on and off, that's the desired state. You're telling the device what you want it to do. The light on top tells you what is the actual reported state of the device, so whether the outlet is on or off. So I wanted to have this distinction because during the demo you can see when I turn it on, there's a little bit of a delay, and then you'll see that the light will turn on. That's the network communications happening. And on the mobile app side, you'd want to connect the mobile app to AWS IoT. There are a couple of ways in which you can accomplish this. First thing is you could use the certificates that you use to have your device communicating with the cloud. That would be the easiest way to get started. Another way to do it would be to use AWS Cognito identity pools. This is a more advanced step, but it's quite simple. You can start off with an unauthenticated identity. So it's the mobile app, there's no extra authentication that's required. It can just connect to your AWS IoT. But this also allows you to use something called as Cognito user pools that will allow you to easily add username login based, username password based login for your mobile app. So what do you do with the Cognito identity pool? You first need to create the identity pool and then enable access to unauthenticated identities. Again, I have a bunch of text here. It might be easier to show you pictorially. So you go to AWS Cognito. You have user pools and identity pools. I would want you to keep a note of the user pools because you're going to talk about it. But we want to go to manage identity pools, and we want to go ahead and create an identity pool. Give it a name, and then make sure that you enable access to unauthenticated identities. And then you're going. It goes ahead and it creates a couple of roles for permissions called auth role and unauth role. We're going to be going and modifying the unauth role, so keep a note of this. And once you have done that, you can also go to your platform of choice. In my case, it's iOS Swift. and you can go and download the AWS SDK for iOS. And it also gives you some code snippets. So in this particular snippet, the main things I'm interested in are the identity pool ID and the region in which this identity pool has been created. By default, it's US East 1. And then next up, I want to go and modify the role, the unauth role that I was talking about, to give it permission, to give this unauthenticated identity permissions to go and access AWS IoT. So I go to AWS IAM, that is Identity and Access Manager, and I would go to roles, and I would pick out the unauth role that was created, which is namely Maker-Faire identity pool unauth role. And right now it has an inline policy already with it. I'm going to go ahead and I'm going to add another inline policy and choose the IoT service and give it a bunch of permissions so it can get the thing shadow, connect, publish, receive, and subscribe. So once I have done this, my mobile app will be able to talk to AWS IoT. Now, after this, I can easily move to a username password-based login using Cognito user pools. So you can go back to AWS Cognito and go to user pools, create a user pool, and then go back to your identity pool and say, this is the user pool that I want to use for my authentication. So in the mobile app configuration, you need to provide it the Cognito identity pool, the region in which you created it, and also the thing name that you're using. So once you have the demo app, you can download it, you can make necessary modifications, and then run it in the simulator, and you should be able to talk to AWS IoT. Then what you're going to be doing is you're going to be getting data from the thing, right? The mobile app receives updates for the device shadow, and then it updates its own user interface elements using those values. Next thing you're doing is interacting with the thing. So I talked to you about the desired state versus the reported state, and here the interaction is only one actuator that I can invoke, namely the outlet. And then when I set that, it sets the desired state, and then the thing gets a delta callback that says, hey, the desired state is different from your reported state, so handle this and do something with it. And then the thing can take that message, and then it can say, oh, I need to turn on this outlet. It sends a bunch of GPIO commands to turn on the relay, and then once it's done that, it can set its reported state to I'm on, and then that results in a message going back to IoT, and then that message comes back to your phone that says, okay, the outlet is now on. All right, now it's time for a demo, and I was wondering if you can switch to the overhead cam. Okay, so this is the my example here. So you already saw the photo of that. So I have it connected via my hotspot right now. So it's really weird setup because it's going through my phone to the internet, and then from the internet it's coming to the phone back to here, but the phone itself is communicating to it through the internet. All right, so I have my app, and you can see that I have a bunch of stuff. So I'd like to be able to see the data and interact with the device locally. So I have the screen and the LEDs and the buttons. A lot of IoT devices nowadays are headless, so the only way that you can interact with them is through the phone. But being a maker, I want to have a personal connection with my device. So you can see here, I don't know if it's quite hard for you to read, but it's showing the voltage value here, but you can also see it on my phone, and it's constantly changing. Right now, the light is already on. That's because the desired state was set to on. So once the device booted up, it got a message that said, oh, the desired state is on, so it went ahead and turned on the outlet. But I can go ahead and turn it off, and it's been pretty quick. It's done a round trip over the network. It's processed the information, and it's turned off the outlet. And you can also notice that when I turn it on, the amount of current that is consumed also rises to 0.01 amp versus if I turn it off, it's pretty negligible. All right. That's it. I think we have a few minutes for any questions that you might have. Thank you. Questions? Over here.
How do you deal with upgrades for things like certificates or DNS root cache file, time zones, and so on?
I'm sorry. Okay.
How do you deal with software upgrades or data upgrades? For example, time zone data is revised a couple times a year. The DNS root cache goes obsolete every quarter. Certificates expire. All these things need to be updated on the devices, the things. How would you approach doing that?
For the time, what I do with time is I follow Zulu time, GMT, so everything is standardized, so I don't have to worry about different time zones. As far as certificate management, yes, that is something to consider. It's something that, it has a limited time. It might be a year or maybe two, but at the end of which you will have to update it. There are certain, in production, like they have the one-click certificate provisioning, right? But there's also, you can have your own certificate provisioning, and you can use your own certificates, and that might help with the process. And if you're doing like over-the-air updates, those things help as well. I think we have time for one more.
Can you comment on, going with Amazon versus rolling your own? For example, you can run your own MQTT server, you can run a HomeKit, you can run a InfluxDB, run your own node to listen to this and all. And so, have you considered that?
Oh, absolutely. Yeah. I mean, the biggest difference is just the speed. First of all, you don't need to buy your own machines, install the software on it, run it. Maybe get a static IP because you might want to access it from elsewhere. If you're going to something like AWS or whatever it may be, Google or some other service as well, using a managed service just gets away from all of the other nitty-gritties. Like, I don't need to install and maintain the software. I just go ahead and I use it, and I pay for how much ever I use. It's just very quick. If you're looking at speed, this is hard to beat. Pardon?
Can you put your link page up?
Oh, yes, and I almost forgot. This example, I'm using high voltage, so I just really wanted to tell people, if you're working with high voltage, please get the help of someone knowledgeable in that area and qualified. I'd like to thank my wife, Archana, for putting up with my crazy schedule and also acting as a sounding board. She's not here, unfortunately, because she's unwell. But here are the resources. So you can contact me on Twitter or my email. This is my GitHub page. So I will be adding this example to GitHub once I have done with Maker Faire and I've cleaned up the code and all of that stuff. And I also have the Dr. Wattson Energy Monitoring Board and the Latching relays available on Chindi. If you're interested, you can go and check it out. All right, so, thank you very much.